Talk about the different approaches between precision and Neuralink.
Some competing approaches to this technology, including Neuralinks, involve doing some amount of tissue damage upon implantation. So the precision system sits on the surface of the brain, underneath the skull and underneath the dura, but on the surface of the brain without doing any damage. So you can see here, it's incredibly thin. It's a fifth of the width of a human hair. We deposit 1,024 microplatinum electrodes on the array, most of which are about 50 microns in diameter. So that is the size of an individual neuron. You can't see it with the naked eye.
This is the human brain, the most complex and least understood part of the human body. It's the very essence of you, your thoughts, memories, and personality. They all reside here. Since the 1970s, scientists have dreamed of connecting the human brain to a computer. This kind of brain-computer interface would help those with disabilities, bypass damaged nerves, restore lost senses, and maybe even provide enhancements. Now, in the 21st century, several startups are racing to build the world's best brain implant. For the better part of a decade, Elon Musk's Neuralink was at the center of the conversation. But now, two rivals are rising up. One of them is led by an ex-Neuralink co-founder. And the thing is, as we'll see later in this episode, even more interesting companies are entering the space. It's a growing industry that's kind of going under the radar. In this episode, we'll explore these companies trying to digitize and tap into the human mind. We'll explore how the tech works, its potential, and take a step back and ask ourselves, is this even a good idea in the first place?
You are watching ColdFusion TV.
A brain-computer interface, or BCI, is exactly what it sounds like. A technology that allows users to control computers or other devices using only their brain activity. And even though it may sound like science fiction, functional BCIs have been around for about 30 years now. But fascinatingly, recording brainwaves go back as far as 1924 with Hans Berger. He may not have invented the hamburger, but he did discover the brain's electrical activity and electroencephalography, or EEG for short. That's the predominant method of measuring brain activity. You might have heard of the cochlear ear implants. These help people hear again by stimulating auditory nerves in the brain. Or you may have seen ALS patients using EEG headsets to control devices with their mind. These are both examples of early BCIs, but these early generation systems suffer from some fundamental limitations. First off, they're bulky external devices with clunky hardware that sits outside the body. Secondly, they only offer low bandwidth connections, meaning that they can only capture crude, basic brain signals. The dream was always something more elegant and discreet, a direct, high bandwidth connection to the brain, something that would let us eavesdrop directly into our neurons' conversations, a device that could read the rich, complex signals of our brain activity and translate it into precise, digital commands in real time. And in 2016, that's exactly what Neuralink set out to build. Founded by Elon Musk and a team of 8 engineers and scientists, Neuralink wanted to design a next-generation BCI unlike anything the world had ever seen. The awkward academic prototypes of the time wouldn't cut it for them. They wanted something that could be commercialized to improve the quality of life for millions of people. The result was a brain implant known as the Link. The device had 2 parts. 1, a coin-sized transmitter that's implanted into the skull, and it sits flush with the surface. And 2, the part that actually goes into your brain tissue, a set of 1,024 electrodes that are distributed across 64 threads, thinner than a human hair. These threads penetrate into the brain tissue about 3 to 5 millimeters deep. These Link chips are implanted by a surgical robot, also of Neuralink's design. Known as R1, it makes the implantation process scalable. The R1 robot inserts these threads into the brain with a speed and precision not possible with a traditional brain surgery. But Elon and his team didn't stop there. They made sure that the Link was bidirectional, meaning that it could read as well as write brain signals. In practical terms, the Link would be able to decode a paralyzed person's thoughts in order to send an email, and also be able to stimulate the user's brain with its own signals. For example, you could theoretically stimulate a blind person's visual cortex to help them see without their eyes. a possibility that Elon Musk shared in a 2025 talk.
Neuralink has had in monkeys a working device we call blind sight. And it's been working well, and monkeys are healthy for a few years now. And we're hoping later this year to do our first device implant for a human, enabling someone who is completely blind to see. It's going to be low res at first, like Atari graphics, so I want to set expectations appropriately. So it'll start off with like very low res, but then over time, I think eventually the implant would enable vision that is like superhuman. So that'd be pretty cool.
When you stop and think about it, it sounds far-fetched at first, but it's a similar concept to the cochlear ear implant, artificially stimulating the brain using external stimuli, although restoring vision is probably an order of magnitude more difficult than sound. It's clear that the potential medical applications of such a device are endless. Restoring movement to people with spinal cord injuries, restoring vision and speech, and further down the line, relief for those suffering from depression, improving memory recall in dementia patients, and so on it goes. But as some of you know, Neuralink's real vision is rather spicy. It goes far beyond just healthcare. Musk talks a lot about unlocking human potential, promising the device would eventually enable telepathy, machine control, and putting humans into a, quote, symbiosis with artificial intelligence, end quote. Make of all of those statements what you will. Anyway, in August of 2020, just 4 years after their formation, Neuralink showed how a device implanted into a pig recorded neural activity from her snout as she interacted with her environment. The following year, they showed a macaque monkey playing Pong using only its thoughts. The company was crushing milestone after milestone and seemed to be at the cusp of transforming millions of lives. Finally, in January of 2024, Neuralink installed its first brain implant into a human patient, a 29-year-old quadriplegic, Noland Arbach. A swimming accident left him unable to move from the shoulders down. A friend and longtime fan of Elon called and asked if he, quote, wanted a chip in his brain. Despite knowing that he'd be the first test subject, he said yes, and without hesitation. Quote, it's always cool to be the first at anything. I think anyone, given that opportunity, would probably do it. End quote. That was Noland in a 2024 interview. Noland's implant was embedded in his left motor cortex, specifically in the part correlated to right-hand movement. Through the Link computer app, the chip translates Noland's thoughts to cursor control. The results are remarkable. He can move cursors, play games, and text with unprecedented speed and precision.
I was not expecting it to be as good as it is. It is something that will learn over time as you give it more data, and not only be able to follow along, but it may also be able to anticipate what you want to do next, just a little bit faster than you can think it.
It was all looking promising, great even, but just a few weeks after this landmark surgery, everything started to unravel. Not even 1 month after receiving the implant, Noland was informed that 85% of the Link's electrodes had retracted from his brain and were no longer responsive. Fortunately, he didn't have to undergo another surgery. A software update fixed most of the problem, but there was a deeper issue here. No one from Neuralink warned Noland about the potential risk, and this is even though the company had seen similar problems in animal trials on monkeys and other test species. This wasn't the first controversy to plague the company though. In 2023, the FDA cited Neuralink's animal testing facilities as having, quote, objectionable conditions. This includes quality control issues and poor record keeping. Some reports revealed that several monkeys died due to complications from Neuralink brain implants. But perhaps the most telling sign of trouble wasn't any external investigation, but the internal disagreements that caused one of the company's own founders to step away. Dr. Penn Rappaport is an extremely accomplished neurosurgeon, electrical, computer, and biomedical engineer. In an interview with the Wall Street Journal, he says, quote, in the early days of brain-computer interfaces, there was this notion that in order to extract information-rich data from the brain, one needed to penetrate the brain with tiny needle-like electrodes, end quote. This implementation method, which the Link relies on, leads to one serious side effect. It always results in some amount of brain damage. When these threads are inserted into brain tissue, they create scarring and sometimes are even rejected by the body, When this scarring occurs, the electrodes can no longer read the brain signals, and this is exactly what happened to Noland. However, Ben Rappaport thought about the problem differently. What if there was a safer, less invasive way to get high-quality data? This clashed with Neuralink's approach. Over there, they weren't so concerned about invasiveness. And here, we have a clashing of heads. The internal disagreements culminated with Ben leaving the company just 1 year after their public launch. And in 2021, he founded the rival company Precision Neuroscience with co-founder Michael Mager. While seemingly operating in the same space as Neuralink, Mager emphasizes that Precision Neuroscience's mission is inherently human care focused. None of that Elon Musk flavored merging with AI stuff or superfluous human enhancement.
So I'm the CEO and co-founder of Precision Neuroscience. We are developing what's called a brain-computer interface. The company that I co-founded, I did so with Ben Rappaport. Ben was one of the co-founders of Neuralink. He's also an active neurosurgeon.
Talk about the different approaches between Precision and Neuralink.
Fundamentally different missions. If you look at Neuralink's website or speak to the co-founders of the company, I think their stated objective is to create some sort of symbiosis between human intelligence and artificial intelligence. That's a fine goal and maybe a very important one, but it's not our goal. I mentioned earlier that Ben is a neurosurgeon, so we are a physician-led company. Really built into our DNA is a focus on safety and patient impact. The goal of this company is to make a really meaningful, positive difference in people's lives. We've done 25 human implants. Our most recent was just on Friday, so this is happening actively. And at different sites, we're able to do different protocols, which are really validating the safety of the system, that we can implant and explant it safely, and the fact that it's working. As well as training the algorithms to be able to do the decoding work that is at the core of a brain-computer interface.
Precision's BCI, the Layer 7 cortical interface, is also an array composed of 1,024 tiny electrodes, but instead of being implanted into actual brain tissue, it's thin and flexible enough to conform to the shape of your brain tissue, kind of like a cerebral glad wrap. The film is 1/5 the thickness of a human hair and doesn't create any damage, scarring, or risk of rejection by the patient's body. It also means it's easily removable. In fact, Precision Neuroscience is focused on creating a temporary implant, which can be used up to 30 days. Another key difference is where the transmitter lies. While fitting a Neuralink link requires permanent modification to the patient's brain, Precision Neuroscience came up with a much more elegant solution. They placed the transmitter under the patient's skin instead. Once removed, you'd hardly be able to tell that the patient has had it, aside from a couple of stitches. This less invasive procedure means researchers can place multiple arrays on the same patient's brain simultaneously. To date, they've managed to place as many as 4 arrays, or 4,096 electrodes on a patient's brain at the same time. Mager claims that this is a world record. Precision has also completed a human pilot study. They implanted their devices in patients undergoing brain surgery, then recorded the brain activity in real time. This provided the highest resolution picture of human thought ever recorded. Precision's president and chief product officer said in an interview with CNBC, quote, "It was incredibly surreal. The nature of the data and our ability to visualize that, I got chills," end quote. But even though Precision Neuroscience offers some clear advantages over Neuralink, there's a third contender who takes the least invasive route of all. Synchron, founded by Dr. Tom Oxley, created a BCI device that doesn't require any brain surgery at all. Instead, Synchron's centrode is delivered through blood vessels. A catheter is threaded through the circulatory system and up to blood vessels on the brain's surface. Here, the device unfolds like a stent. It's actually the same procedure used for treating strokes. Minimally invasive, well tested, and like the other two methods, requires no incision into the skull. But of course, there's a trade-off. For the Synchron device, the signal quality is less. By sitting in blood vessels rather than directly on brain tissue, Synchron's device captures less detailed neural information, at least when compared to the other two. But that being said, for basic functions like controlling a computer cursor, sending texts, or operating smart home devices, the signal is strong enough. Synchron has already achieved permanent implants in 10 patients and received FDA approval for longer-term clinical trials. Their approach represents the safest entry into brain-computer interfaces and the lowest surgical risk. But okay, let's turn things up a notch here in this episode. What's a race with only 3 participants? There's one more company that we should look at, and they've recently made a breakthrough. Blackrock Neurotech. Founded in 2008, it's one of the oldest and most experienced BCI companies on the market. And I know what some of you might be thinking. Blackrock and brain-computer interfaces don't go together. It sounds like a dystopian nightmare. But despite the name, Blackrock Neurotech has no affiliation with Blackrock Investments. Their latest chip, the Move Again system, uses a rigid grid of silicon microelectrodes that penetrate the cortex. With just 96 to 128 electrodes per array, its bandwidth is quite low compared to the other devices, and its rigid structure makes placement less flexible. But that's not holding them back. This device enabled a paralyzed man to speak again, and he spoke in his own voice thanks to their technology. The implant reads his brain signals as he tries to speak, then feeds them into an AI-powered decoding model. In just 10 milliseconds, they're converted into audible speech created using past recordings of the patient's voice.
We recently implanted a 45-year-old man with ALS who really can't be understood when he tries to speak very easily. And by using a BCI, we can translate his desire to speak and have words appear on a screen.
Not being able to communicate is so frustrating and demoralizing. It is like you are trapped.
But we can also accurately predict what he's trying to say in free-form conversation.
A lot of the demonstrations of BCI technology over the past few decades took weeks or months to get working. The first time he tried to use the system, it just worked.
Okay, ready?
That first time that he tried to speak and that word appeared on the screen, he started crying, I started crying, his family started crying. Basically everyone, we had to pause. We stopped the rest of that block of experiment trials. Everyone composed themselves and we're like, all right, let's do it again. And it kept working. So yeah, it was really special. It was a special moment.
With just 30 minutes of speech training, the system achieved an astounding 99.6% word accuracy.
Which is better than a lot of commercially available smartphone applications that try to interpret your voice, which hover around 95%. This is by far the most accurate decoding ever reported.
That was David Brandman, neurosurgeon and co-leader of the study. Quote, previous speech BCI systems had frequent word errors. This made it difficult for the user to be understood consistently and was a barrier to communication. Okay, this is cool and all, but as this industry continues to grow, which hopefully you can see by now that it is growing, and as more players enter the market, we have a bigger question to worry about. Should we even be doing this in the first place? Many people feel instinctively uncomfortable with the idea of merging brains and machines. It challenges our notion of human identity and consciousness. But on the other hand, what does it say about us if we don't use this tool to improve the lives of those suffering from debilitating conditions? When trying to answer questions like this, it can be helpful to break down the potential applications of the brain implants into 4 categories: treatment, prevention, enhancement, and augmentation. Treatment is any medical application that makes the patient's outcomes or quality of life better. Things like helping the blind see. Then there's prevention. This could be things like giving BCIs to people with a genetic predisposition to different neurological conditions. So far, we're within the realm of medical applications. But if we venture into non-medical applications, this is where things get murky. Using BCIs to enhance existing traits or augment humans with entirely new ones is a whole different story. If rich parents gave BCIs to some children to give them a photographic memory, the ability to see more colors, or faster reasoning skills with an actually accurate AI system, does that really seem right? Furthermore, if society was eventually divided between enhanced humans and unenhanced humans, what would that mean? It could open a Pandora's box to an eerily dystopian future. If we look 5 to 10 years in the future, there are also legal questions to consider. If at this stage in the future, brain data becomes easily readable thanks to advanced algorithms, who owns the data generated by your brain? Where should it be stored? And what are the legal acceptable uses for this data? And what happens if these systems are hacked? Imagine the powers that could be given to advertisers and governments. If it calms any nerves, Precision Neuroscience's CEO says that the FDA has things under control.
Data security and data privacy questions are really built into the regulatory regime that the FDA enforces. This is a highly regulated industry for good reason. And it's not the case where companies are able to move fast and break things. The FDA is very prescriptive in terms of the data security and data privacy issues, as well as the fact that we operate within the HIPAA regime.
Now, for argument's sake, let's leave aside those with disabilities that need it most. So where do we draw the line for non-medical applications of BCIs? Some will say we should never start toying with it at all. Others might think that a little bit of enhancement is okay. Unfortunately, at this time where we sit at the very beginning of the advancement of this kind of technology, there is no straightforward answer. But one thing is for sure, finding out that answer as the technology progresses will be a wild ride. But I'd love to hear what you guys think. The idea of merging mind and machine has been science fiction for decades. But as the BCIs move from labs into clinics and eventually to consumers, we'll all have to ask ourselves not just what's possible, but what is worth doing. And the decisions we make might just define what it means to be human. What are your views on this? Are you for BCI enhancements or think it's a bad idea? Let me know in the comment section below. As you've seen, some of the breakthroughs in brain-computer interfaces were made possible with the help of AI. Now, AI is a confusing term, but it is a lot more than just generating text and images from prompts. It's making real changes in the medical field. But what if you wanted to clear up the confusion around AI? What is AI and how does it work? Well, that's where today's sponsor, Brilliant.org, comes in. Brilliant is where you learn by doing, with thousands of interactive lessons in maths, science, data analysis, programming, and AI. They have a course on how AI works. It covers everything from large language models to neural networks, tokenization, and loss functions. Each lesson on Brilliant allows you to play with concepts, a method proven to be 6 times more effective than watching lecture videos. I find Brilliant useful for refreshing myself on key subjects. Plus, all content on Brilliant is crafted by teachers, researchers, and professionals from MIT, Caltech, Duke, Microsoft, Google, and more. Learn at your own pace to brush up on a project for work or just for your own self-development. Try everything Brilliant has to offer for free for a full 30 days. Visit brilliant.org/ColdFusion or click the link in the description and you'll get 20% off an annual premium subscription. Thanks. Anyway, that's about it from me. My name is Dagogo and you've been watching ColdFusion, and I'll catch you again soon for the next episode. Cheers guys. Have a good one.